So for this question, we're going to reverse a stack, and we are going to put the reverse value back in the same stack, and we can use an extra stack and a temp variable. So for example, our input could be, our stack can look like this, and then it should look like this at the end. So what we want to do basically is we're going to have a temp, we have a temp variable, we have another stack, and we have our original. So the idea of it is that we're going to pop that first element and put it in a temp, because eventually we're going to want to put this our temp variable into here while once this stack is empty. So we're going to move our 2 and our 3 here. So now our 2 is going to go here and our 3 is going to go here, and now our temp is going to go back in. Now we can push everything else back into the original stack, being 3, 2, and it's going to be the same concept. So our 2 is going to go back here, and now our 3 is going to go here into our extra data structure. But since our 1 is already in the correct position, we don't necessarily have to push it back. So we're going to have a count that kind of like that as we're iterating through our element in our original stack, we're going to take minus 1 or minus the current index, so that way we don't kind of go back and put the 1 here, since it is already sorted. Not sorted, but it is already reversed. So same concept, we're going to move our 2 here, and now our 3 is going to go back there. Yeah. So how this is going to be is we are going to have, so we have our function, and it's called reverse stack, and it's going to have our original stack, and now we're going to have a temp stack as well. So let's have the temp stack, and we're going to have a temp variable. So for temp, it's going to be nothing right now. So we're going to, since we want to kind of like iterate, we kind of want to like look at every single value, or like do as many iterations as there are elements. So we're going to do a for loop. So for var I equals 0, I is less than the original stack. It's going to be our size, and we are going to increase. So now we are going to pop our first element. So our temp is going to be our original stack pop, and now since we already have that element, we're going to kind of like do the back and forth. So let's just like we have to, for the many variables that are currently in the original stack, we have to put in the temp stack once we have already popped that temp variable, that first variable, that first element, I mean. So let's keep a counter. So we have a count, and our count is basically going to be right now the original stack size, and we're gonna do this while our count minus the current index, because of, like what I explained earlier about, we don't have to, once that first value is already in the correct position, we don't have to continuously move it back and forth. So I'm just going to do, like, take that into account. While that is greater than 0, then we are going to kind of like pop that first element and push it into our temp stack. So our temp stack is going to kind of like, we're gonna add a new element from our original stack. So original stack dot pop. So we have that. So that should be in there, and we're going to since we have one less element in our original stack, we are going to decrement our count. And kind of like now that we have, so eventually we're going to move all those elements from here to there, and now we want to move all those elements back. But before we do that, we do want to kind of like push that temp variable into our original stack. So we're going to get our original stack, and we're going to push our temp. So now it should look something like this. And now we kind of want to do the same, but for all the other elements. So we're going to do another counter. And we're going to, again, get the size of the temp stack now. So we're going to get the temp stack dot size. And we're going to do, again, the while loop. Kind of like the same scenario, but kind of like interchange. So now we are doing accounts. Now I'm not going to incorporate the minus I because we have to move all those elements. All of them, we can't keep one in. So while count is greater than 0, we are going to we're going to push into original stack that push the pop values of the temporary stack. So temp stack dot pop. Oh, and I forgot, we have to decrement our counter. So now it would kind of like iterate through everything. And what we want to do now, since we have kind of like gone through every single for as many times as there are elements in our original stack, now we're going to close that for loop, and we are going to return our original stack. And that is it. Oh, and as far as time complexity, we are already iterating once, so that already is an n. And we are looping twice for the count. So we are, oh, and we have a while loop within, so that's already kind of like nested. So that's already n squared for time complexity.